Hi, hello everyone. Hi to all my legends in the classroom. So I can't see the energy. Where are you all? You have to be with full of energy, right? Because you all have done with your weekends and I know that you all had enough fun. So this is the time to study and I know that you all are here with a fully loaded energy in the classroom. So yes, this is Ameer, your physics educator at an academy and you know what you all have to do. Jaldi se jaldi give me an amazing thumbs up in the chat box. Everyone go for it. And let me also know how much of energy you all are going to be giving to this entire session and how all excited you all are. Go for it quickly. Dinner to nahi kiya Ritu. I just went out and I had some snacks. That's all I had. What about you all? Have you all had dinner? I feel like having the dinner after all my classes, watching a TV and watching some show and all. I'm doing good, Anna. Sugam, Sugam. Good evening, Sanuj, Aditya, Anna, and hi to everyone in the classroom, right? A big hi to everyone. And I hope you all are happy. So, don't you all want to know what is the topic for today's session, right? So, as this is a very last lecture of alternating current, in today's session, we'll be covering transformers, right? The only topic that is left to cover. And we are going to revise this entire chapter in today's session. Don't you think it's amazing? Yes, it is so amazing. So, that is what we are going to do. Hi, Sophia. Very good, Bharat. Very good. Very good. Okay. I'm so happy that I was also a part of it. And whoever is seeing me for the very first time, a brief introduction about myself. Myself, Ameer, I have an experience of more than 3.5 years in the field of teaching. I'm a BTech graduate from NIT Calicut. I have taught and mentored many students. They are doing so well in their life. And this is the schedule for this particular month, right? Till 17th of it. As you can see, tomorrow we'll be having the Menti quiz. And on 15th September, we'll be having EM waves, electromagnetic waves in one shot. We'll be covering the entire chapter in one particular class. Then we have ray optics. Okay, we'll be starting with ray optics. Wow, that's amazing, isn't it? You know, so many amazing educators are already there in Unacademy Class 11th and 12th YouTube channel, right? So I know that you would love to learn with all of us. So if you want to get updates of all the classes at the right time, it will be an amazing idea to be a part of Telegram channel. The link is given right there. Click on that link and be a part of it. Jaldi se jaldi. Bugs Bounty, how many of you know what it is? It's an amazing way which will help all my variants and legends in the classroom to get so much of prizes. What do you all have to do? You have to go to the description box. There you will find a form. Okay? Fill in the form if you're finding any inappropriate content in any of the video uploaded by Unacademy. Right? And one last thing, I'll talk 1 minute about this Unacademy subscription. Right? Then we'll start right with our classes. Fine. Now, why we all teachers ask you to be a part of Unacademy family? It is simply because, right, there in the Unacademy platform, we'll be teaching with a proper schedule, right, targeting all the exams such as NEET, JEE and the board exam, which means everything is going to be in super order, right? You can track of every topics that we cover and every kind of studies that we do, which means the studies, Anna, the study is going to be super simple. It is going to be. And you know that top educators of the country are already available in Unacademy platform. So I know that you'd be loving, right, to be a part and to learn with us, right? So, and more than that, you can actually come in the classes, you can actually chat with us, you can make that student teacher bonding with us. Okay. So you can get some advices, mentoring, everything. So it's going to be so much amazing, right? You will feel refreshed and motivated all the time. And yes, more than that, study material will be given to you so that you don't have to roam around looking for books from where to learn. Practice tests and live test series will make you super duper confident and will bring the best out of you. For all these things, right, you should be going for the plus subscription. For plus subscription for 12 months, it will cost you 1,250 per month, and for 24 months, it will cost you 1,042 per month. I know that you are all looking for an amazing discount. So just use this code AMB10, which will give you a 10% of discount. Okay. And those who love extra amazing features while you learn with Unacademy, it would be better if you go for the iconic subscription. Because in iconic subscription, a personal mentor will be given to you, okay, which means a person will be there to help you throughout your academic activities, and live doubt solving classes will help you to clear all your doubt when we teachers will come live, and in the live classes you can ask your doubt and get it cleared. That's an amazing feature, don't you think? Weekly report will help you find out your performances and find out your weak topics so that you can improve your weak topics and improve your performance and score. And for all these amazing features to be enjoyed, for 12 month subscription will cost you 2,333 per month, and for 24 months it will cost you 2,000 per month. चाहिए ना डिस्काउंट? चाहिए ना? बोल दे हाँ सर बिल्कुल चाहिए, हमें चाहिए. बोल दे बोल दे बोल दे. तो here is a code for getting extra 10% of discount, which is AMB10. Okay, so that's it. Now it's time for studies. If you all are ready, to finish off this particular chapter of alternating current, just show me some love and energy in the classroom. I'm in the chat box. Jaldi. So we have Aditya, Sophia. I'm so happy right now. I got laptop. Okay, Bharat, you got a laptop because you scored well. Wow, that's an amazing thing. You are super excited for today's class, and I'm so happy to know that. So everyone, are you all fully energized? Okay, with full of energy, are you all sitting on your chairs with a smile like this, right? You can just thank me by being here and learning with me all the time, Bharat. That's more than enough, right? And just keep on giving me love and share the classes. Ask your students also, which means friends also, to come and join. Hi Karan, hi Dani. So I think it's time for the classes to get started, right? So here we go. Now let us have a very quick recap of whatever topics we have learned in yesterday's classroom. Tell me, how many of you do remember the topics that we have covered, right? The first thing is remembering the topics, right? So yes, we have learned about power factor. And after power factor, we have learned about LC oscillation. These were the main topics we have focusing in yesterday's class. What was power factor, right? Cos phi was power factor. And why we need this cos phi? For finding out the power of any kind of L, C and R circuit, isn't it? How will you find out the average power? That is equal to IRMS, right? VRMS into cos phi. And this cos phi was actually called as power factor, isn't it? And how will you find this value for phi? It's very simple. I have taught you impedance triangle. If you mark phi as this particular angle, opposite side is XL minus XC. This is R, this is Z. I hope you do all know what is XL. What was XL? Right? Inductive reactance. What is XC? Capacitive reactance. R, normal resistance, and Z is the total impedance. We have covered all these things, right? Then we have also learned about LC oscillation. Yaad hai? Which means if you are having a capacitor which is completely charged, let's say, hai na? If you connect this capacitor across an inductor, okay, what happens the moment you complete the circuit, right? The charges will start flowing, will produce a current, right? And you will see that there happens an oscillation of what and what? The electrical energy stored inside the capacitor and the magnetic energy stored inside the inductor. It keeps on oscillating SA. What was the angular frequency of oscillation? Omega value kitna tha? That was 1 by root LC. Isn't it? Till here we have completed yesterday's class. Hai na? I hope you do all remember this. Yes or no? Now what is left? Let us do a problem from the topics that we have already covered, right? And let's see how much we understood and how much we still remember. That's what we are going to do. Ready hai na pura ka pura log? Okay, so I think everyone is so awesome and everyone is really waiting for this question to be completed. Let's see. A coil. A coil means, I hope you all know, right? A coil, right? A coil or a solenoid. A coil will always be coming along with a resistance, right? So whenever it is being specified as a coil, right, you have to mark an inductor along with the resistance, right? Okay. And a capacitor. So which means what we have is an LCR circuit. That's it. It is connected across an AC source of RMS voltage 20. So we are connecting it across an AC voltage of 24 volt, isn't it? Right. By varying the frequency of AC, a maximum RMS current of 6 ampere is observed. When will you get the maximum value of current? Whenever the circuit is in, बोल दे. We have learned whenever the circuit is in resonance, we get the maximum value for the RMS current, isn't it? Yes. At resonance, we know that the XL value, inductive reactance, will be equal to capacitive reactance. याद है ना सब लोगों को, है ना? और क्या सर? ठीक है. Now, if this coil है ना, which we not the entire LCR circuit, I'm only taking that coil, is connected to a DC battery of EMF 12 volt and internal resistance of 4 ohm, then the current through it in steady status, right? We will go step by step. Then you will be understanding this particular question in a better way, right? So first what I'm going to do is, first I'm going to find out the unknown resistance here, right? Okay, how will I find? Because in the AC circuit, potential is equal to 24 and the current passing through the circuit is 6 ampere. How can you make an equation out of this? How can you make an equation? Current, voltage and resistance, I is equal to V by R. The total resistance of an LCR circuit is Z, the impedance, right? I is given as 6. Voltage is given as 24. And what is the formula for Z? The total resistance of an LCR circuit, root of R square plus XL minus XC the whole square. Isn't it? Yes. And it is simply specified that this LCR circuit is in resonance. In resonance, XL value is equal to XC value. Isn't it? Yes or no? We have learned. So just substitute the same over here. When XL is equal to XC, this becomes 0. XL minus XC will become 0, right? At resonance. So this will be 24 by root of R square, as R is 6. अरे मिल गया तो मिल गया. आपको क्या मिल गया? The first part of the question is done. That is 24 by 6. ये हो जाएगा how much? 4. So we got the value for resistance as 4 ohm. Okay. कोई गड़बड़ नहीं. I think you all understood this concept, right? It's a beautiful concept. Lekin this is not our question. What is our question? What is our question is, you know that coil is taken separately. Coil along comes with a resistance. And this resistance is what we have found out as 4 ohm, right? This is connected now across a DC. DC matlab a battery is connected, a direct current. It is not a variable current, a direct current, right? It is connected with an internal resistance of another 4 ohm. Okay, it is connected. Now the question is, the current through it in steady state is, what is the value for the current? Array, this is given as 12, right? What is the value given? At 12 volt, right? Okay. Now it is given as 12. Now how to find the answer for this? Now what all you have? You have 2 resistances and 1 inductor. Okay. What is the equation to find out the resistance of an inductor? That is equal to L omega. Yes or no? But tell me, what is the value for omega if you are applying a DC? A direct current if you are applying, what is the value for omega? What is the value for omega? It's 0. Omega means angular frequency, right? As we are applying a direct current, it is not changing, so angular frequency is 0. So if you put omega as 0 here, XL becomes 0, right? Which means no resistance is offered by the inductor in this particular circuit. So we only have 2 normal resistances in circuit which is in series, isn't it? So how will you find current? Array, current is equal to V by net value of resistance. Total resistance, net value matlab total. What is V? V kya hai? What is V? Total potential is 12, right? And total resistance in series 4 plus 4. 4 and 4 are in series. So total resistance R equivalent is, R equivalent kitna ho jayega? It is R1 plus R2. So that is 4 plus 4, that's 8. So this becomes 3 by 2 or 1.5 ampere. Anybody have given the answer? Huh? Okay, Rotash, I'll soon. Okay, is this question clear? If this question is clear, it simply means you know the concepts of LCR circuit in depth. That's what it means. Jaldi bol de. I'm waiting for the answers from all my amazing legends in the classroom. Okay, clear. With full of love. Bharat, very good. Thank you so much. Ani Thula Bus. I can't even understand what is being written by some students. Because we are in India, we are having so much of languages, isn't it? It's a good thing. Unity among diversity. Hi Sana, good to see you. Sophia, clear? Manasilai, okay. So everybody got the concept. So now what we are left is the very last topic of this particular chapter, transformers. Right? So let us understand this concept in deep. First question. Is there anyone in the classroom who haven't seen a transformer? Okay, I think everybody might have seen, and some of you might not have realized that this is a transformer. I'll describe what is a transformer, right? Let's say you are going on a road, right? Okay, you are walking, you are on a vehicle. You might have seen, I'll draw the picture. I'll try to draw the picture. You might have seen in between two electric posts, a heavy, huge system will be made like this, right? A heavy, huge system will be made, and on top of it you'll be seeing the word as danger, khatarnak. Is the khatarnak the right word? I have no idea. And it will be written danger, and on it will be written that 11 kilovolt, 11,000 voltage is passing through that, right? A heavy system is what you can see, right? So I think everybody might have seen this is simply transformers. Okay. Okay, so why we need this huge system in the middle of the road? There must be some very heavy and useful purpose for it, right? Don't you all want to know? Let us understand, right? You know that it is in powerhouses, right? The electricity is generated. So electricity is generated in the powerhouses, right? Now you are using the same power or the same electricity in your own houses, right? How is this possible? Because the electricity is being taken by the transmission lines, right? Two lines will be coming or three lines will be moving over your head. You might have seen that, right? And it will be coming to your houses, right? This is what happened. This is general scenario. Now this particular current has to travel a very long distance for reaching your houses. Current, electricity, right? This electricity has to travel long distance when it is passing through these wires, right? So whenever a current is passing through a conductor, obviously it will be having resistance. So what happens? A lot of energy will be lost. What happens? A lot of energy will be lost during the transmission of electricity from the powerhouses to your actual houses, right? So in order to reduce the amount of energy lost, what we will be doing? What we will be doing, or it is advised that voltage has to be kept high whenever it is being transmitted through the transmission lines. Which means, let's say in the powerhouses, the current is produced with a potential of 440 volt. So in order to reduce the energy loss, what it will be done is, this will be made to a very higher voltage. Let's say 22,000 voltage, it will be stepped up. Okay, why we are increasing the voltage of the current that is produced from powerhouses? So that we can reduce the energy loss when it is passed through the transmission lines. Okay, so the current passing through the transmission line is of very high voltage. Now are you going to use the same to 22,000 voltage at your houses? No, you only need a 230 volt at your houses, right? So just before the electricity comes to your houses, a process of changing the potential from or voltage from 22,000 to 230 volt will happen, right? So in between this transmission, you might have noticed two things. What are the two things, right? The two things are, from here, when it is being transferred from powerhouses to the transmission lines, the voltage has been increased. And when it is moving from the transmission line to your houses, the voltage is being decreased. So there has to be some machines or some devices, some electronic equipments right, to change this voltage or to make happen change in voltage, right? And this device is simply called as transformers. So it is the duty of these transformers to change the voltage from lower to higher or higher to lower. समझ में आ गया? So that we can save energy to a very large extent. Okay, इधर तक आ गया, समझ में आ गया अच्छे से? Okay, so I think everything is clear till this part. Okay, everything is clear. Thank you so much. Now, now we are going to give separate names for two transformers, right? Or we are going to classify transformers into two. Which are the two transformers? So the first kind of transformer is called as step up. So what will this transformers will be doing? It will be taking a lower voltage into a higher voltage. So if the voltage is increased, we call those kind of transformers as step up transformers. So isko kya call karta hai? The transformers kept near to your houses, that is called as, अरे बोल दे, simple. It is called as step down. क्या कर रहा है? We are taking the voltage from a high value to a low value. This is called as step down transformer. Bas. So there are two kinds of transformers, step up transformers and step down transformers, right? Okay, very good, very good. Now, before we move to the working of transformers, you must be knowing how these transformers work, right? Okay, in between there's a huge device which you'll be seeing in the middle of the road. What is actually inside? Don't you all want to know how it is actually working? So for understanding the working of transformers, you should be knowing about mutual induction and self-induction. किस लोगों को याद है? How many of you do remember about mutual induction and self-induction? How many of you are having a smile once you hear the word mutual induction and self-induction? That says you all do remember these concepts. शिवम कुमार सर, अपने आप को फदा रहे हो क्या? ये क्या? So बोल दे, transformers, what we were talking, right? How many of you do remember regarding the mutual induction and the self-induction? Nobody? Okay, so I'll just brief you so that you can refresh about the ideas regarding this mutual induction and self-induction. देख ले. Now, let's say I'm having a coil here. What do I have? I'm having a coil. So if I pass a current of I through this coil, right, a current carrying conductor will be producing a magnetic field. B is produced. Okay. Now if I pass a current which is varying, which means a changing value of current, if I passes through this inductor, what will be produced? It will be producing magnetic field, but as current is changing, it will be producing a changing magnetic field. Okay. Now, near to this coil, I am placing another coil. What I am doing? I am keeping another coil, let's say coil 2. Okay, there is no current, no source of energy or no source of current is actually there in the coil 2. Now, let's see what happens. Now, as the second coil is placed in a region where there is a changing magnetic field, what happens? The flux associated with the second coil also changes. I hope you do all remember regarding this fluxes and everything. I'm not going deep into that. You are supposed to learn from the chapter of electromagnetic induction and we have learned it, right? So yes, the flux associated with the second coil changes, and when the flux associated with it changes, an EMF is produced in the second coil. Formula that is equal to rate of change of flux associated with it. And as there are n number of coil, let's say n2 number of turns are there. So the induced EMF is equal to n2 times d phi by dt. I hope you do remember. This is called as mutual induction. okay, inducing an EMF in a coil because of the changing magnetic flux produced by the neighboring coil. Okay, now how many of you do remember self-induction? Self-induction, this is the coil, okay, this is the second coil. Because of the mutual induction, an EMF is produced, N2 divided by d phi by dt, isn't it? Okay, now let us understand about self-induction, not understanding, just revising or refreshing your mind, because we already have learned. Now, as we already have learned, a current is passing and let's say a changing current is passing. A current produces magnetic field. A changing current produces a changing magnetic field. A changing magnetic field. Now you have to know that the first coil, right? The first coil is placed in a region where there is a changing magnetic field produced by itself. What did I say? The first coil is placed in a region where there is a changing magnetic field produced by itself. So what will happen when the field changes? The flux changes. When the flux changes associated with a coil, an EMF is induced. Formula N1 into d phi by dt, isn't it? What is E1? E1 is the self-induced EMF in the coil 1. So that is equal to N1 into d phi by dt. ये N1 क्या है? N1 is the number of turns in the first coil. Bus, right? If you know this much, right, the working of transformers is very simple. Please talk in Hindi. ठीक है, मैं तो हिंदी में अरे यार, this is my Hindi. How do you think? Okay, I'll be explaining anything in Hindi with this. Okay, मुझे थोड़ा थोड़ा आता है. In between I'll be using some Hindi words to entertain you. बस और कुछ याद नहीं है मुझे, और कुछ आता भी नहीं है हिंदी पे. Okay, so have you all copied these two things? This is the simple, basic and fundamental thing regarding what? Regarding the working of transformers, regarding the mutual induction and self-induction on which the transformers is working. Is it clear till this part? So Bharat is here, Chunit is here to help me out. Thank you. Okay, so let us try to understand the simple structure of a transformer, right? It will be having an iron core, ऐसे, okay? It will be having an iron core like this. ठीक है, iron core तो है. So this is our iron core. Now over this iron core there will be two windings. And you see, this is the first winding. We call the first winding as the primary coil. What do we call this? We call this as a primary coil. Now let's say this is having a number of turns N1. Now there is another coil on the other side of it, and this we call it as the secondary coil. Okay, now it is across the primary coil we will be supplying the input. So the input is provided in the primary coil. So we have the input, it is provided in the primary coil. Input means let's say the current coming from powerhouses. Okay, the current coming from powerhouses, right? It is given across a primary coil. So the input is given. Obviously, it is an alternating current. A current which changes its values, right? If a current which changes its value, a changing magnetic field is produced. Same concept. Current changing its value, changing magnetic field is produced, and EMF is induced across a second coil. Formula we already have written. It is equal to N2 d phi by dt. ये क्या है? What is this? ये क्या है? E2 क्या है? E2 is the EMF induced across the secondary coil N2 d phi by dt. And obviously, because of self-induction, what is it? Because of self-induction, an EMF is induced across a primary coil. Formula N1 into d phi by dt we already have explained, right? Okay, so as you cannot see the resistance in the primary circuit, what did I say? As we cannot see, or as we are not giving any resistance in the primary circuit, in the ideal situation, whatever is the voltage given, which means whatever is the input voltage, okay, that will be equal to the EMF induced across a primary coil, because there is no other resistances, right? So whatever is the voltage that you provide to the primary coil, that will be entirely dropped across that particular inductor, which means formula N1 into d phi by dt. So now you have EMF across the first coil and EMF across the second coil. Clear? Okay. Now you know that wherever there is physics, there is always ideal situation. So it is only on the basis of ideal situations we make the equations. Ideal situation means an efficiency of 100%. How is an efficiency of 100% possible? Is it possible to have an efficiency of 100%? सोच कर बता दे. बिल्कुल नहीं. Is it possible? This is only an ideal case. No machines in this entire world can be having an efficiency of 100%. बिल्कुल नहीं. This is not at all possible. There will be always energy losses. Energy will be lost from the system. But physics है ना, some ideal cases we have to consider, right? So only on the basis of ideal cases we have to make equations, which means we think that the efficiency of this transformer is pakka, which means 100%. Pakka. ठीक है? If efficiency is 100, it simply means whatever is the power in the primary, okay, whatever is the power in the primary, the same will be the power produced in the secondary circuit, right? Because efficiency is 100, no energy is being lost. ठीक है? How will you write the power in the primary? That is voltage in the primary, right, into current in the primary, right? And how will you write the power in the secondary? That is equal to voltage in the secondary into current in the secondary, right? So now we will get a relationship between voltage in the secondary by voltage in the primary, that is equal to Vsy Vp is equal to Ip by Is, which simply says they are inversely proportional, which means the current and the voltage in the circuit are inversely proportional. वो तो हमको इधर से मिल गया तो मिल गया, है ना? कॉन्सेप्ट भी मिल गया, समझ भी आ गया, बोल दे. So we got the voltages in the circuits are inversely proportional to their current, or voltage in the secondary by voltage in the primary is equal to current in the primary to current in the secondary. This equation is very, 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 very important from this part of what? Transformers. बहुत important है. Shall we make one more important equation from this transformers? That is the first part. The second part is, देख ले, what is the EMF in the primary coil E1? That is N1 d phi by dt, isn't it? Okay. Now, what is the equation for EMF in the second? That is E2 equal to N2 into d phi by dt, है ना? सच में. So we have equation of E1 and E2. Divide E1 by E2. E1 by E2 will be equal to N1 by N2. d phi by dt is common, cancel हो जाएगा, है ना? So shall I write the same thing as such in the second? No confusions, right? So E1 by E2 is equal to N1 divided by N2. So another super duper duper ka upper ka important equation, right? EMF in the first, which is primary, to EMF in the secondary is equal to number of turns in the primary to number of turns in the secondary. Okay, or instead of writing E1 by E2 and N1 by N2, right, you can write in terms of primary and secondary, right? Okay, so shall we make all these two equations into a single one? Okay, shall we make the ultra powerful equations? Okay, now E1 by E2 is N1 by N2, which means they are directly proportional, right? Or if you write in terms of secondary and primary, instead of using 1 and 2, EMF in the secondary to EMF in the primary is equal to number of turns in the secondary to number of turns in the primary. This is equal to, how will you write the equation for current? देख ले. Voltage or EMF in the secondary to EMF in the primary is equal to inversely proportional to their current, right? Let us write the same. So EMF in the secondary to EMF in the primary is equal to inversely proportional to their current. Current in the primary to current in the secondary. So if you connect the first part and the last part of the equation, how it is going to be? Current in the primary to current in the secondary is equal to number of turns in the secondary to number of turns in the primary. Next part of the question. Bus? Okay. So ES by EP is equal to EMF in the secondary to EMF in the primary is NS by NP. Very important formula. And the second part of the formula is current in the primary to current in the secondary is equal to inverse, right? Number of turns in the secondary to number of turns in the primary. But another important. Can you all by heart all these equations? Huh? Legends in the classroom, jaldi bol de. Can you all by heart all these equations what we have just written here? If you all can do that, and if you have already done that, I think you already have done that, right? And those who haven't taken down the notes, please note it down all these equations jaldi. You're feeling sleepy and you want to study. Kya karna hai, okay? So whoever is feeling sleepy, what you all have to do, just put your hands up, okay, as you all can see, and stretch yourself अच्छे से, okay, and right and left अच्छे से कर ले, and just stand up, okay, and just make a 2, 3, 4 jumps. Bus, okay, have a sip of water. You'll be back with full of energy. Start learning. You are new student Sneha Tiwari. Welcome to the classroom, Sneha, and let's all learn together with a smile. So I think this concept is clear to everyone, right? Bol do na zara. So concept is clear. Ready for the questions, everyone? Type of transformers we have learned, right? Before we start moving, okay, I'll talk about energy losses in the transformers, right? After we do 1, 2 questions, right? We'll talk about it. Don't worry. So yes, here we go. I want every one of you to give the answer in the chat box. I'll be looking into the chat box. Okay. So Shivam, Kunal, Sana, Avinash, whoever have understood this particular concept will be giving me the answer. Fatafat. So a transformer has 50 turns in the primary. Okay. Number of turns in the primary is 50. And 100 in the secondary. Number of turns in the secondary is equal to 100. Okay. If the primary is connected to a 220 volt DC supply, so EMF in the primary is 220, what will be the voltage across secondary? What will be the voltage across secondary? सोच कर बता दें. Think about it before you give the options. Let me see who was actually listening to the class. I can't see the correct answers till now. I'll give you last 10 seconds to answer. Last 5, 4, 3, 2, 1. Very good, Bharat. Amazing. Yes, it is option C. What does option C says? The EMF is equal to 0. Hare, how can there be an EMF in the secondary? How can there be an EMF? The EMF will only be induced because of what process? Because of the mutual induction we already have discussed. And the mutual induction happens when there is a changing current which produces changing magnetic field, which produces a changing flux. Then only an EMF is induced in the secondary. But you have to look and underline the voltage is a DC, not AC. A direct current is being applied. If there is a direct current, no changing flux, no EMF induced. So secondary EMF is 0. Rhythm गलत हो गया, कोई बात नहीं है ना. So try not to make the same mistake again. That's how old the life is. Sir, I'm in class 11. मेरे subject 1-1 हो गया. Please, I'm in class. अरे यार, इधर से पढ़ ले, हमारा पूरा का पूरा various and legends के साथ पढ़ ले. We always believe in the magic of learning together, isn't it? बोल ले various and legends. So I hope this is done, right? Okay. Now, let us see how can I explain the concept of step-up transformer and the step-down transformer based on the equation we have. which means EMF in the secondary to EMF in the primary is equal to NS divided by NP, right? We already have learned this. Now, look into the equation. If the number of turns in the secondary to number of turns in the primary is a larger value, let's say this is 1000 divided by 250. Number of turns in the secondary is 1000 and number of turns of the coil in the primary is 250. How much this answer is going to be? 4. Right? So by connecting the first and the very last part of the equation, ES by EP will be equal to 4, which means EMF in the secondary is equal to 4 times EMF in the primary, which simply says if the number of turns, try to connect, this is very important, if the number of turns in the secondary, if it is more than the number of turns in the primary, the EMF in the secondary will also be more than the primary. Here in this case it is 4 times, right? So if number of turns in the secondary is greater than the primary, the EMF in the secondary will be more. Such kind of transformers, what do we call? If the EMF is increased, if there is a large value of EMF in the secondary, what do we call? Usko bulata hai hum with a sweet name. Us sweet name kya hai? Step up transformer. I think you all have watched the Step Up movie, dance wala. Hai na? So here we have transformer. Okay, actually a combination of 2 movies. Okay, Step Up dance movie and Transformers fighting movie. I love Transformers. I think you also love, hai na? Acha movie. It's a good movie. So is it clear? What did I say? If number of turns in the secondary is greater than number of turns in the primary, the EMF in the secondary will be more than the EMF in the primary. Such kind of transformers we already have explained. Step up transformer. Arey step down kya hai? Step down kya hai? Obviously, if the EMF in the secondary is lesser than the EMF in the primary, we call it as step down transformers. When will it happen? When will that happen? Look into the equation. EMF in the secondary to EMF in the primary is equal to number of turns in the secondary to number of turns in the primary. So, if the number of turns in the secondary, if it is lesser than number of turns in the primary, this ratio will be lesser than 1, right? If this is lesser than 1, it simply means EMF in the secondary to EMF in the primary is lesser than 1. If EMF in the secondary to EMF in the primary is lesser than 1, it simply means ES is lesser than E primary. So, if number of turns in the secondary is lesser, the EMF across the secondary is also lesser. This kind of transformers, kya bulata hai hum usko? What is a sweet name given to these kind of transformers? Itna acha wala. What do we call that? We call it by the name of step down, because voltage is getting down, नीचे हो जा रहा है. So इसका नाम है एक और बार, one last time. Yes, this we call it as step down transformers. समझ में आ गया? Very good, Anna. Step down. Yes, Sana. So is it clear? Shivam, Sanika, and everyone in the classroom. Now, I hope you all are noting down the important concept. This is super important topics, okay? It is not necessary that all these concepts you will be finding in the textbooks, okay? Some extra points will also be given. Okay, now moving on. We have found out all these equations, right? We have derived all these equations based on the fact that there is an efficiency of 100%, right? Which means no energy is being lost. But that is happening only in the ideal case. In the real life situation, can you make any device with 100% efficiency? Bilkul nahi. Obviously, there will be loss of energy. Bilkul. Obviously, there will be loss of energy. So, in a real transformer, let us understand what are the different ways of loss of energy. First is a flux leakage. What do you mean by the concept of flux leakage? Do you remember this concept we have taken? The process of mutual induction. Okay, I have told when a current is passing through this coil, it produces a magnetic field, right? The magnetic field is associated with this coil also, right? Which means a flux is associated with the second coil, phi 2. Now, We have assumed that the efficiency is 100% based on the fact that whatever is the number of magnetic field lines produced by the first coil, let's say 100 field lines, 100 FL means 100 field lines are produced by the first coil, right? If there has to be 100 efficiency, all that 100 field lines should be associated with this coil for the production of EMF. But it never happens enough. If it produces 100, only 50 lines will be going through this particular coil, let's say, and some of the others will be passing through here and there, which means so many field lines are being lost, which means so much of energy is being lost. Okay, this concept we call it as flux leakage. Flux is leaked. All the flux lines produced by the first coil is not passing through the second coil, right? So because of that, energy is being lost. So we have first का क्या है? हाँ, flux leakage, one of the reasons, one of the biggest reasons for the energy loss. फिर resistance is there for the wires. When there is resistance, if current is passing, heat energy is produced and there will be loss of energy in the form of heat. We have learned eddy current. What is eddy current? Eddy current is a current produced where current produced current. Can you see these coils, the primary coil and secondary coil, where it is wound? It is wound on soft iron cores, right? Which means on a core, which means a conductor materials. So this is a metallic conductor, right? A volume of a conductor. This is also placed in a region of changing magnetic field, which means a changing flux. So a current is produced in this conductor also, right? In that entire solid. And the current produced in metallic conductors, that current we call it as eddy current, a small refreshing. We have completed eddy current in our previous classes. So just refreshing your memory. So if there is current produced in the metal, it will be producing heat energy. And again, energy is being lost in the form of eddy current heat energy also. Right? Okay. Then the fourth reason is hysteresis. What is hysteresis loss? We call it. We usually say that as hysteresis loss. What is it? Because you know that the changing magnetic field will keep on magnetizing that conductor materials here and back, right? So if it keeps on magnetizing the materials, right, and if it keeps on changing the direction of magnetism induced in that material, right, some energy is being lost. That is called as hysteresis loss. I think you all have learned in your magnetic effect chapter. Okay, so yes, so these are the different reasons for energy loss in an actual transformers. Okay, thank you Fazan. So इधर तक clear है? Okay, are you all ready to do the questions? बोल दे everyone with full of energy, with smile on your faces, with that interest for learning new concept. बोल दे जल्दी से. हाँ sir, we are totally ready. We are totally ready to learn more concepts and to do more problems. Where are you all? Nobody wants to do the problem. Jaldi. Sana, yes, pin Allah ready. So Sana is all ready to rock the session to do the problems. What about others? Bharat, yes. Okay, so everyone is back. Everyone is full of energy. So let's start doing the problems. Here we go. Yeah, ready, Sophia? Good. A power transmission line feeds input power at 2300 volt. So EMF in the primary is 2300. Okay. Now to a step down transformer means voltage is being reduced with its primary windings having 400 turns. So number of turns in the primary is 400. No, 4000, it's not 400. What should be the number of turns in the secondary? Number of turns in the secondary is a question. In order to get an output power at 230 volt, which means EMF in the secondary is equal to 230. For how many of you the concept and the equation is clicked? For how many of you have a smile on your faces? Anna has already given the answer. Let's check, right? So what is a simple equation connecting all these four? EMF in the primary by EMF in the secondary is It is directly proportional. Number of turns in primary, number of turns in secondary. Okay. Primary EMF is 2300. Secondary EMF is equal to 230. Number of turns in the primary 4000. Number of turns in the secondary unknown question mark. Okay, कर सकता है, कर सकता है, हाँ सर बिल्कुल कर सकता है. So 230, 2310, right? So NS is equal to 4000, 230 by 2000, okay, 100 will be removed, and what it remains is 400 number of turns. So the number of turns in order to get an output power at 230 volt is equal to 400. If you know that equation, simply put the values in the equation. Okay, you just need to open your hands so that the answer will be just falling into your hands, I say. Okay, look how easy the questions are from transformers. Okay, yes, 0.4K. Okay, it's fine, but there is no necessary for writing in that way. Anyway, that's also correct. Finally got correct. Amazing, amazing. बहुत बढ़िया बात है ना. So Sanika, tea Bonvita asta means, do you drink Bonvita or I have to drink Bonvita? I have no idea. Whatever. Right? Good evening, Ayush. Shall we start doing the next problem? Jaldi bol de, jaldi bol de. With a smile, bol de. Yes, sir, we can do. Bol de. I think you all have said, yes, sir, we are totally ready. Now let's hit the next question. A transformer having efficiency of 90%. So the efficiency of the transformer is 90, which means output power is equal to 90 by 100 of input. That 90% of input is actually the output power. That is what you mean by efficiency. I hope you all might be knowing this, right? Okay. A transformer having efficiency is working on 200 volt and 3 kilowatt power supply, which means EMF input is equal to 200 volt, okay, and the power input is equal to 3 kilowatts. That is, they claim 3 into 10 power 3 watts. So I just have written whatever is given in the question bus. Next, if the current in the secondary coil is 6 ampere, what is given? So I in the secondary is equal to 6. Done. The voltage across the secondary coil, first question. E in the secondary, question. And the current in the primary coil. So current in the primary. Okay, done. So how to find out these two unknowns of this particular question? Simple, है ना? Simple, या नहीं? Is it such a difficult question? Everyone can do it from your side. It is not a very tough question. So try to give me the answer as soon as possible in the chat box. Jaldi. Okay, so in the meanwhile, I'll also be doing here. First, let us find out what is the current in the primary. How? Because input voltage is given. Input voltage is equal to, right, EMF input into current input. Right? What is given as the power input? That is 3 into 10 power 3. Isn't it? And what is the input voltage? Input voltage is 200. Input voltage is 200. Substitute that 200 into II. So current is equal to, zeros cancel, 30 by 2, that is 15 ampere. Mil gaya to mil gaya. First part of the question is done. Okay. Now, how will I find out? What should I be finding out? The EMF in the secondary. Current in the secondary is given. So, in which direction your mind is actually moving so that you can find the answer? If it was me, I'll be going for output power is equal to EMF output into current output. Okay, what is given here? What is given here? If the current in the secondary current is given 6 ampere, E0 has to be found out. This can be found out if there is any method to find out output power. कुछ है? Is there any method for finding output power? That is how the question itself is starting. देख ले, a transformer having efficiency of 90%. So how will you find out output power? 90 by 100 into input. Input is 3 into 10 power 3. है ना? So cancel कर ले. 0, 0. है ना? One more 0. This will become 10 power 2. So 3 into 10 power 2 equal into how much? 9. Right? This is the output power. And how do you write the output power? That is equal to 6 E naught. 6 E naught is equal to output power. So E output, the potential output, is equal to 9 into 3 divided by 6 into 10 square. So 3 6 are 2, 9 by 2 is 4.5. So this is a 450 volt. देख ले कितना आसान से मिल गया हमको, है ना? So our correct option is current is 15 and voltage is 450. So it is option B. आ गया? Any doubts? If anyone is having, please let me know. We'll be clearing it out before we proceed. All these questions are very important. Actually, these are basic questions only. We are doing all these questions by using the formulas that is already being derived. आ गया तो आ गया, समझ तो आ गया ना बिल्कुल. आदित्य विनोद, you didn't slept. Okay, किससे पूछ रहे हैं आप? So clear till this part. Okay, jaldi se jaldi give me a thumbs up and do let me know that no one is sleepy out there and everyone is totally waiting for the next question. Jaldi jaldi, we want to start the next question as soon as possible, right? Where is दो दिल मिल रहे हैं मगर चुपके. Okay, so maybe after the class, if it is possible, I'll sing. So yes, I can see the smiling faces from Kunal. Anas given me thumbs up. Ritu has given me thumbs up. Mr. Thinker has given me thumbs up. So yes, it's time for the next. A power transmission line feeds input power at 2300 volt, right? So power input, sorry, not power input, at 2000, array yaar, that is input voltage is given, right? My bad, really sorry. So a transmission line feeds input power at 2300 voltage to a step down transformer with its primary windings. Okay, so number of turns in the primary is equal to 4000. Okay, the output power is delivered at 230 volt. So V output is equal to 230 volt. V output or E output, whichever you want to use, you can use. Okay. Next, if the current in the primary of the transformer is 5 ampere, so current in the primary is equal to 5 ampere and its efficiency is equal to 90, the output current will be equal to. So power output is equal to 90 by 100 into power input. Okay, question is the output current would be I output is a question mark. Okay, so yes, let us start finding out the method to find out what? The method to find out the I output. So V input is given, V output is given, right? So V input is given, V output is given, I primary is given and I output is not given. Kaise? Don't you all remember V output by V input is inversely proportional to what? The current. So I input divided by I output. We already know this formula, isn't it? So just put the values in there in the formula which you already know. What is V output? That is 230. And what is V input? That is equal to 2300. That is equal to I input. What is I input? Input current, I primary, if the current in the primary is 5, yes, 5 is there. I put, we don't know. Right, so how much we can make use of it? Okay, now let me tell you the small issue, right, which I also have made, right, when doing this problem. The simple issue I have made in doing the problem is, this is the equation which we use. This is the equation which we use when there is 100% of efficiency. Is there 100% of efficiency here? Bilkul nahi. There is only an efficiency of 90%, which I also forgot to apply it here. So I don't want any one of you to make the same mistake. Understood? Okay. So let us write the same thing. It is given in the question that output power is equal to 90% of input power. That's what it is explained in what that is what explained in what the efficiency. What the formula for output power? Jaldi bol de, jaldi bol de. What is output power? Output power is equal to V output into current output. This is 9 by 10, right? Cancelling one zeros, right? What is a power input? So V input into current input. Bas. Now we can just start substituting all the values. Bas. So V output 230, V input is 2300, V output is 230, 9 by 10 into V input is 2300, right? Okay. Then current in the primary is 5, so current in the primary is 5. So I naught has to be found out. I naught, how much will it be? So 2300 by 230 is 10, 10, 10 cancels, 9 5s are 45 with the unit of amperes. बस इतना ही है. Only this much. There is only this much to learn. Is it clear to everyone? Hana, yes, it is 45 ampere. Yes, 45 ampere. Sophia, very good, amazing. बहुत बढ़िया बात है. Is it clear? Okay. Now, how many of you want to make a quick revision of this entire chapter? Whatever we have learned till now. So, the chapter is over. How many of you think, sir, just tell everything related to this chapter so that we can understand which are parts we are missing? है ना? So, Mr. Thing tells that, yes, I want to learn a bit more, which means I want to make a quick revision. You want to make a quick revision, Anna said. अपन को करना है, ठीक है, अपन को करना है तो अमीर सर है आपके पास. Only 2 students want the entire revision. Bus. Only quick revision. Mr. Thinker and Anna wants. Sana wants. Very good. So I can only see 2-3 people who really want the revision. But even if it was one student who told me, sir, I want the revision of the entire chapter, I would have done. But I am expecting more, everyone's energy, everyone's everyone's excitement, okay, and everyone's brain along with me, right? So whatever, let's give a next 15 minutes, right? But 15 minutes more. So give me that 15 minutes. It will be a very quick revision of entire chapter, right? Okay. Now we have started this particular chapter by talking about average current and the RMS current of an AC circuit, right? How to find out the average of any value? Formula is integral of I dt by integral of dt, right? Whichever quantity is average you have to find out. So integral of I dt by integral of dt, right? I hope you do remember this equation. Now, what was the average value of voltage and current for sine functions and cos functions? Let's say current I is equal to I naught sine omega t. What is the average value? What was the I average? I average was found to be 0. I hope you do remember earlier class, right? If something is not clear, please do watch the first session and do understand. Then we have learned IRMS, the root mean square value of a given quantity. So how will you find? That is equal to I naught by root 2. isn't it? Yes. Then we have started learning about what the alternating current, which means AC, started apply across resistor, capacitor, inductor. What was the result you have seen? If it was connected across a resistor, if you are applying an AC across a resistor, what was the phase difference? Delta phi. Yeah, there. Delta phi for a resistance circuit, it was 0, isn't it? Then after that, how to find out the current here in an resistance circuit? That is very simple. That is V by R, right? I think I don't need to explain that because you all know how to find out a current, right? But the problem comes once you have a capacitor applied across an AC. There is a phase difference of how much? 90. Yeah, there is a phase difference of 90 in the circuit. Yes, sir. Bilkul yaad hai. And then what was the equation for resistance? We call it as capacitive reactance formula 1 by C omega. And with this phase difference, why don't you all tell me who is actually leading or who is actually lagging? Who's actually leading and lagging in a capacitor circuit? In a capacitor circuit, current actually leads, है ना? Current leads in a capacitance circuit. Ana 2 I naught by pi is the average value for the half cycle. For the full cycle, if it is sine or cos value for anything, for the full cycle it is 0. Okay, please do watch the replay. I have completely explained that. Then, if it was an inductor circuit, inductor है circuit पे, and if you are applying an alternating current across it, right? What is the phase difference? Phase difference is pi by 2. But here, who is leading? Yes, the voltage leads here, है ना? कौन lead कर रहा है? Who's the winner here? हाँ, voltage, बस. And what is the resistance of an inductor circuit? Inductive reactance, we call it XL. Formula is L omega. है ना? And just like current is equal to V by R, how will you find out the current in each of these circuits? Current I in this circuit is equal to voltage by its resistance, that is XC. है ना? And how will you find out the current in an inductor circuit? Voltage by its resistance. वो क्या आता है? XL. इतना ही है. आ गया तो आ गया, इधर तक आ गया, कोई गड़बड़ नहीं है, कुछ भी गड़बड़ नहीं है. Any doubts you have, if you can ask me. Is there any free pages available so that we can start scribbling and okay, so we'll continue here, right? Okay, now देखिए, now if you are having an LCR circuit, an inductor, okay, a capacitor and a resistor in the circuit, if you have, tell me everything you have learned or try to remember everything that you have learned. This is L, C and R. Tell me how to find out the phase difference. Tan of phi is equal to, how to find the phase difference? XL minus XC divided by R. So how will you get tan phi, cos phi, all kind of phi's? You just have to remember the impedance triangle. Mark this as phi. Opposite to phi is XL minus XC. Adjacent is R, right? And the hypotenuse is Z. The total resistance, we call it by the name of impedance. What is the formula to find out impedance? Hypotenuse, okay? The square root of one side square plus another side square. Hypotenuse, how will you find out? Arey yaar. है ना? So this is how you find out. Root of R square plus XL minus XC, the whole square is the total impedance of an LCR circuit, right? Anything more to be reminded of from this particular part? I don't think so, right? Then after this, we have learned about resonance. What is it? We have learned about resonance. Resonance, what was the concept? The resonance is the concept of current passing through an LCR circuit to be having the maximum amplitude, and this happens when XL is equal to XC, which means the inductive reactance is equal to capacitive, that is L omega is equal to 1 by C omega, omega square is equal to 1 by LC, or omega is equal to 1 by root LC, which means the resonance happens if the frequency of the oscillating current is equal to 1 by root of LC. So the current will be oscillating with the maximum amplitude. Okay, we call this as oscillating frequency or resonance frequency, we actually call it, or natural frequency also is possible, right? And when will the quality of this resonance be more? When the quality factor Q is more. Formula L omega naught divided by resistance. Okay, इधर तक कोई गड़बड़ नहीं है. I hope you do all remember all these concepts. Any doubts you have till here, you can ask me. I'm looking into the chat box. Okay, so I think it's clear till this part. No doubts. Everything is super clear. मैं तो बहुत बढ़िया लक्ष्मी. Good to see that energy even at this time. Everything is clear. Very good. So shall we proceed and talk about two more concepts? Okay. Now let us see. Okay. Now let us see what is a power factor. Right. Power factor I think already have explained you at the beginning of this particular class. But anyway, right. So the equation to find out the average power for any circuit, right? For any circuit wherever there is an AC source connected across an inductor, capacitor and resistor. Formula क्या है? VRMS, okay, IRMS into cos of phi. And what is this cos phi? This cos phi is called as power factor. How will you find out this cos phi? I already have told you what the impedance triangle. Opposite is XL minus XC, adjacent is R, hypotenuse is Z. Okay, so these all are the important points of this chapter. You can mark it and write it down if you want it. Now, if you really think you want to score very good marks from this chapter. Okay, then we have learned about LC oscillations, right? So the oscillation of electrical energy and the magnetic energy if an capacitor and inductor are connected together, right? What is the angular frequency with which they oscillate? Omega is equal to 1 by root LC. Okay, yes, is it clear? Omega is equal to 1 by root LC. And after that, today we have learned the very last topic for this particular chapter, which is a transformers, right? Step up transformer, step down transformer. EMF of the secondary to EMF of the primary is equal to number of turns in the secondary to number of turns in the primary, right? This one, isn't it? And current in the primary to current in the secondary is equal to number of turns in the secondary to number of turns in the primary. They are inversely proportional. Okay, everything is clear, Anna. Okay, so how many of you are going to be there for tomorrow's Menti quiz? For the Menti war, the time for all the legends to show how much they are capable about, how much they have learned this particular chapter. कौन आएगा? Tomorrow's class exactly at 10 p.m. From Monday to Friday, we'll be having the classes exactly at 10 p.m. Yes, don't you all want to know who is going to be on top of the leaderboard? Clear? Sana, Neetu, Sanika, Sophia, yes. Yes, I know that, Anna. Very good, very good. Sure, I'll try to make a Prakash. I'll try to make a one shot video for the chapter 4 and 5. Okay. Yes. So कोई गड़बड़ नहीं है. Is everything clear? Are you all having a smiling faces? So I hope you all are going to be on top of the Menti war tomorrow, right? And let's see how amazing it is going to be. So don't forget, tomorrow at 10 p.m. we'll be having the Menti war. Great. Okay. Now that's the entire thing about this particular chapter. And right, how many of you know regarding the special classes? How many of you know regarding the special classes that happens on the Unacademy platform? Okay, and you might be thinking, if it is in platform, we'll have to pay for it, right? No, the special classes are entirely free. And you know that the special classes are with so much of fun, and it is too much interactive. Why? Because there is real time chats and emojis can be done, right? And there you can ask me all your doubts in the question tab, and I'm supposed to clear it. And a live poll for quizzes and the leaderboard will make it super interesting, and will help us understand who have actually scored very good in these particular classes and who was there actively and learned that particular chapter. So on this Wednesday, I'm conducting a on this Wednesday, there is a special class, not a special class. There are two special class from my side, right? Exactly at 4:30 p.m., right? And at 6 p.m. When? On Wednesday. Which are the topics? On 4:30 p.m. on Wednesday, we have the chapter of gravitation, right? And 6 p.m. we have torque and angular momentum, right? We'll be discussing the important concept, multiple choice questions, then NCERT problems. So don't forget, Wednesday 4:30 p.m. gravitation and 6 p.m. torque. So those who haven't joined till now for the free classes, what you all have to do, it is completely free. You just have to download the Unacademy learning app, log into the app and click on the menu button on the top left corner of the app. You'll find the special, right? From the drop down you can find a menu as special. Click on it and do apply the invite code. What is the invite code? AMB Tech. So use this code so that you can be a part of the special class for free. So I think you all want to complete learning about gravitation, and you can also learn about what the rotation and torque. These are important topics for this particular competitive examinations also. Let's say AE or NEET. You all want to write it. You all want to score good. So these topics are very important, right? Thank you so much, Anna. Song to my guitar is in the other room, Sophia. Right? So kal to pakka I'll sing for you. Just remind me. Yes, I do take classes for 11th Neeto Devi. It is at every day 8 p.m. Every day 8 p.m. I am taking classes for 11th. Okay. Song tomorrow, pakka, pakka. Actually, my guitar is not here. Okay, I'll be bringing it in tomorrow's class and I'll be singing. Pakka, pakka. Okay. So thank you so much for being here and making the class awesome. Okay, and yes, let's all meet tomorrow. And those who haven't liked the session, jaldi se jaldi like kar le and show me how much you all love me and how much you all love physics. So you can just show me that. Anyone here who haven't shown how much love you all have for physics? And it is just a way to appreciate whatever we all teachers do, right? Just click on the like button and do let us know that, हाँ sir, आप तो अच्छा कर रहा है. You are doing good for all these students, right? It will be like a motivation to all these teachers like me. And a small thing, if you are going for plus an iconic subscription before 13th, right? You'll be getting extra 4 months free for 12 month subscription, and you'll getting 6 months free for 24 month subscription, right? And extra flat 10% discount you will get if you use the code of AMB10. Okay. So yes, Bye everyone. I hope you all do. I hope you all subscribe to the channel. Right. So yes, thank you so much once again. Bye everyone, and take care.